Got it.
Okay, so thank you all of you that you joined this session. So today with Kris, we are going to talk about our weekend projects. I will say, as you can expected, me as well. I was really surprised by the impact that DeepSeek has. And while it was like Saturday evening, I was reading some Reddit and Substack articles, and then everyone was talking about DeepSeek. So I got interested, and I decided to build this project that today we are going to present with Kris. So in particular, we will talk about how to build, evaluate, and deploy AI agents that use one of the distilled DeepSeek R1 models on Vertex AI. But before to do that, let's go back a little bit. So if you start building LLM-based application like 3 years ago, probably you start from this point where you use LLMs as a API to inject to pass some prompts in order to achieve some task. So this kind of scenario, when you start working on it, it resulted so excited, but suddenly it shows some limitation, right? For example, one of them was related to hallucination. The LLM incorporate some knowledge of the world outside that was not up to date, for example, to the request that you were submitting. So in order to solve this issue, like RAG application or RAG architecture, they came out, right? And the idea is essentially to provide some up-to-date context to the LLMs in such a way that it can handle also, all the requests from the users that were not integrated in their in its knowledge of the world. So in terms of, training data set that has been used to create the LLM itself. This kind of architecture resulted so impactful, but at the same time, he has some challenges, some limitation related to the lack of concept understanding that the RAGs was generating, as well as some of the people perceived the response of the RAG architectures kind of superficial. And so that's why like we moved from RAG to agents. And when you look at the agents, essentially what we can say is that an agent can be defined as an LLM-based application that try to achieve some goals by observing the world and acting with it using some tools in a way that it can handle the request of the users. Now, I'm not like a super expert in agents, and that's why today we have Kris that spent most of his time building agents. But if you have if you really want to know how to build agents, what are the main pattern and the components of the agent itself, I would really recommend to have a look at these white papers about agent that we published recently. And as far as I know, also Kris contributed, and because it could be very insightful, especially if you are starting, building agents today. But with that said, let me to introduce ourselves with Kris, and then tell you what are the two questions that today we want to answer. So I'm Nardini. I'm a DevRel engineer. I'm working mainly on helping people to bring their own models or their own tools and build a powerful AI application on Vertex AI. And today with me, I'm so excited to have Kris. Kris, if you want to introduce yourself.
Yeah, absolutely. Hi, everyone. Kris Overholt. I'm based out of the Austin, Texas area. I'm a developer relations engineer. I work on Yvonne's team with all things Gemini and tools and agents. And we're super happy to be here. I think the big three takeaways for this are we always talk about platform, not model, which means there's always going to be new models coming out. It seems like every week or every day now. And so we're very happy to look at things like Model Garden and think about how can, Google is a very open ecosystem. How can we use models like this to power our Gen AI apps? We're also going to look at evaluation, like Yvonne said. And finally, we'll look at deployment. What does it mean to take a generative AI app, an agent, which is really kind of an LLM program, and what does it mean to deploy that on Vertex AI, knowing what we know about microservices and models. So we're super excited to dig into some of that today. And so, Ivan, one cool thing about this workflow that you've built is that, and you did it so quickly, in the last few days after DeepSeek came out, is you had kind of this pipeline already, right? And you'll talk about that in a moment, but you had this pipeline already. You evaluated Gemini, you evaluated our partner models, Claude, and now you just kind of plugged in DeepSeek as a tool with an agent and really exercise it in this really cool evaluation framework. Is that right? And so that's why we're here. I come from kind of the agent tool top level down, and Ivan comes from evaluation and model up, and we meet in the middle. And though we're on the same team, it's kind of neat to look at how one builds when you think about that. And it just shows, it's good to have different people in your team to think about. Hey, I'm thinking about deployment, and Ivan's thinking about eval, and others are thinking about other pieces. So we're super excited to dig in. Let's do it.
So as I said, Kris, we want to answer two main questions today. And the first one, it's how to evaluate an agent, right? So if you start building agents today, probably whatever framework you use, it can be LangGraph, it can be CrewAI, and today we are going to use the Hugging Face Mole agent framework. Essentially, all these framework, in order to evaluate an agent, they provide you two main output with respect to the input that the user passed to them. And the output are represented by the response and the set of tool that the agent use to generate the correct answer with respect to the user input. So that's why, like, when you think about evaluating agents, like the two things that you can evaluate is whether or not the agent achieved the goal, looking at the response that it generates, and evaluating the sequence of tools that the agent took in order to reach the final answer. So this is important because if you have the user input and then you have just the response and the trajectory to evaluate your agent, you can build several kind of methods and metrics in order to try to understand how the agent is good in achieve the task that you have in mind when you design it. And at the same time, you have different methods to measure this kind of KPI from the agent. So one of the methods for sure is that you can ask subject matter expert to analyze both the response and the tools that the agent uses, and define with them some criteria. So, for example, decide that in order to have an agent that is capable of achieving the task, it needs to be, it needs to be efficient. So it needs to generate the answer in a certain time range, as well as the answer needs to be, human-like, especially if the agent, for example, is something that you want to use with a customer-facing application. So with this subject matter expert, you can define with them what are the methods, and then they analyze the input of the user, their response, and the set of tools that the agent generates, and they evaluate. They assign some, score to the agent. The problem of this approach is that, as you can imagine, is time consuming because you need to generate several answers, and then it requires some time to subject matter experts to analyze the response. It is expensive, of course, and it is also difficult to scale because imagine if you have like a factory of agents, one per each use case that you want to implement. And also it is something subjective. So an agent that can be good for, in my opinion, my personal opinion, maybe it cannot be the same for Kris, for example. But at the same time, like this kind of approach, it allows us to, capture some nuanced behavior and aspects related to the agent. But in order to, overcome these challenges that I just mentioned, so it's time consuming, it's expensive and difficult to scale. Another way that you have to evaluate agents is using an LLM as a judge. Essentially, you use another LLM and you try to, specialize them in analyzing the results of the agent, so the response and the set of tools that the agent use, passing him some examples, the same criteria or similar criteria that you were also defining with subject matter expert, and of course, like a ranking in a way that the LLM is able to associate, some scoring, has a scoring rule to assign to the response and the trajectory that the agent use in order to achieve the task. This like method to analyze to evaluate the agent it has its own straits. So it's scalable because you rely on the scalability of the agent. It's efficient, and depending on how the agent is good in the evaluation task, it can be also consistent. The problem is that it really depends on the LLM capabilities. And also, like imagining a complex scenario when you have multiple agents. It's not easy to understand, like it's not easy to apply an LLM on all these agents and try to understand, like, okay, is the agent A generated a response that is useful for the agent B in order to achieve the same task. So it can be really tricky to orchestrate this kind of evaluation across different agents. So that's why the last method that I want to highlight in this presentation is that you can always define automated metrics, right? And with automated metrics, essentially because you define some mathematical formula that you can control, it gives you a little bit of, it gives you a little bit more, you are a little bit more confident on the kind of, the evaluation that you generate. So the scores, the metrics that are associated to the response and the set of tools that the agent creates. The thing is that this kind of metrics, for sure, you cannot, define metrics that are that evaluate how the agent is good in reasoning. There is no math formula that tell us how good an agent can be in reasoning. So you need to adapt a little bit the criteria and of course the metrics that you calculate in order to evaluate the agent. But this using automated metrics, it will allows you to be a little bit more objective, and for sure it's a method that allows you to scale and be more efficient. But as I said, it doesn't capture all the spectrum of capabilities of the agent, right? So at the end of the day, these are more or less all the methods that you have to evaluate an agent. And at this point, it should be clear for you that there is no one method that is better than another. All of them, they have pros and cons. So at the end of the day, it's not about choosing just one method. It's more about building. So evaluating an agent is more about building or getting access to a toolkit of quality controlled and explainable method and metrics that allows you not only to observe the behavior of the agent, but also monitor the agent with respect to the use case you are building and at scale. So in order to make this task, so providing you like having access to this tool of metrics and method, as a Google Cloud, we build a services which is called Generative AI Evaluation Services on Vertex AI. So I don't know how many of you know Vertex AI, but essentially is an AI/ML platform that provides you a set of services to scale, to build and scale both machine learning and AI application, including the LLM-based application that nowadays we build, and so RAG agents, as we are going to discuss today. So in terms of the evaluation capabilities, the general evaluation services provide the methods and metrics that allows you to evaluate a different kind of LLM-based application, not just agents. But the most important things that I want to highlight is that this framework is completely open. So it doesn't matter which kind of LLMs you are using. It can be a Google proprietary model. It can be an open model, as we're going to show you today. But the framework is designed to integrate any API and evaluate any application that use an LLM-based API in order to provide you a better overview on the evaluation on the application itself. So it's designed to be scalable and customizable. So when I say customizable, I mean that you can include some custom metrics. And this is so important because despite the fact that we provide some metrics, pre-built metrics, of course, having custom metrics allows you, to adapt the evaluation to your use case. And it is designed to, support you during the experimentation phase. In fact, it is also integrated with Vertex AI experiment tracking services. So each time that you run an evaluation, all the metrics and the parameter they're going to be tracked in Vertex AI experiment, which is a managed experiment tracking services on Vertex AI. For agent evaluation, which it has been recently launched, we integrated the metrics that we were already providing for evaluating other kind of application for with the agent-oriented metrics. So we have more than 50 metrics to evaluate the response of the agents, and we have more than 5 metrics to evaluate the trajectory. So the set of tools that the agent use in order to achieve a particular goal. And once you run the evaluation, you get insights both at the instance level, so per each user request, as well as at the aggregated level. So you get some, an overview that gives you an idea how good the agent is compared to the task you are testing it for. And one of the most important things, which is related to the second part of this presentation, is that this framework can be integrated with reasoning engine. So which is a services that allows you to scale your agentic application on Vertex AI. But Kris is going to cover this into detail. With that said, let's jump into the demo. So I want to show you how it is possible to use, to build and evaluate an agent using the generative AI evaluation services. And in this particular scenario, the one that we are going to cover to the demo, we are going to use a small agent framework from Hugging Face, and we are going to use one of the distilled DeepSeek R1 models as a tool in order to verify some math facts. So with that said, let me jump quickly into the demo. So for people that are new at Vertex AI, this is how the UI of Vertex AI looks like. So as I said in the presentation, here you have several services to build both generative and predictive AI application. And today for this demo, we are going to use one of the notebook services that we have on Vertex AI, which is a Colab Enterprise. Essentially is an enterprise version of Colab, which I will assume some of you use every day to prototype with the AI/ML use cases. So the goal of the demo is building an agent that use DeepSeek R1 model as a tool, right? So first of all, we need to deploy the DeepSeek R1 models on Vertex AI. Thanks to Vertex AI Model Garden and the integration with Hugging Face, we are able to collect the DeepSeek R1 model from Hugging Face and deploy it in a self-managed way on Vertex AI. All you need to do is using the Vertex AI SDK, which you can see here. And the first step is register the version of DeepSeek model that you want to use on Vertex AI model registry. So, which is a place where you can manage, the model that you are going to deploy on Vertex AI. So it's interesting because when I start building this demo, I approach it as a person that didn't know much about DeepSeek. So the first thing that I did, I went to the Hugging Face page. I checked how to deploy this model. They suggested to use a VLLM serving environment, which is something that we provide on Vertex AI as well in an optimized version. So what I did, I just took the container, the VLLM container, inference container from Model Garden, Vertex AI Model Garden, and I passed the parameter that were suggested by Hugging Face for this particular model. And I registered the model. So this is the first step in order to deploy DeepSeek on Vertex AI. Then once you register the model, all you need to do is associate to the model that you want to deploy, that you just register an endpoint, and the resources that they are going to be used by the model in order to generate the prediction. So this is how to do that. So with the SDK, you are going to create the endpoint, passing some information related to the name of the endpoint itself. And then you use the deployed method, passing the kind of resource that you want to use. In this case, we are going to use an NVIDIA L4 as a GPU. We are going to use just one of it because it's enough with this kind of model, and a G2 standard 12 machine type in order to serve DeepSeek R1 model. So once you have done this, I already done this because it takes some time, the model will be available to the endpoint. So using the SDK, you can submit a prediction request. So in this case, we are going to ask the model to count the number of R in the word strawberry, and like in a couple of seconds, you will receive the response of the model that essentially tells you how many R's are in the strawberry. And because we are in the strawberry word, and because we are in the demo, so there is always the demo effect. In this case, it said that there are 2, but usually it's pretty good to say that there are 3. So once you have the model deployed, you can build your agent, right? Because you have essentially you have the endpoint that you're going to call with the tool. And in order to build this agent, we use the small agent library. So what I did, I simply built a math agent tool that essentially you can use to ask a mathematical question, and then use a Gemini 1.5 to orchestrate the response. And essentially, Gemini will call a tool that uses DeepSeek 1, in this case, the Queen 7B bundle, to verify if the response is correct, is mathematically correct. And then if it is correct, then you can return the response to the agent. So in order to do this with Hugging Face, small agents, you need to build a couple of classes. One that allows you to use Gemini as an orchestrator of the agent. So this is how my code looks like in this case. So you can see that we are leveraging the integration that the Gemini API has with the chat completion API. So you can easily integrate this the API of Gemini with this framework. So once you create the class to handle the orchestration, which is going to use Gemini, the other step is building a tool that is going to use the DeepSeek 1 model that I just mentioned as a verifier, as a math verifier. So the code is pretty much similar. The only thing is that you need to provide some name, some description, and the kind of input that the tool expects to receive. And then I just wrap the code that I show you to call the model in a Vertex endpoint in this class in order to generate the math verification using DeepSeek. Once you have done this, you just need to assemble the agent using the small agent interface, and then you can start using your agent. So in this case, we ask him, hey, how are you? And it generates the response using the interface that Hugging Face tools, the Hugging Face small agent uses, which in this case, it's called a code agent. So essentially use some function in order to generate the response of the agent itself. And this is how the response look like. So you can also, print all the steps that the agent use in order to generate the response. So we can do the same with the response that with the request that I showed you before. So we are asking now the agent to count the number of R in the word strawberries again. And what is going to happen is that this is the plan that is the agent is gonna use to generate the answer. And you can see as at some point is gonna use the math verifier tool that we built in order to double check the response that the agent generate. And if it is correct, then it will explain why it is correct, and it returns the correct answer, which in this case is 3. And again, you can print, all the execution to double check the final response and the set of tools that the agent uses. With that said, we have the agent. So now let's evaluate the agent. In order to evaluate an agent, all you need to do is building an evaluation dataset with the prompt that the user passed to the agent. And if you want to evaluate how the agent is good in picking the right tool, you need also to pass the expected tool that the agent is going to use in order to answer the specific request from the user. So in this case, again, we have count the number of R in the strawberry word. And then what we expect, according to just what I showed you before, is that the agent is gonna initiate this variable, it's gonna count the number of R, and it's gonna add, the number of R in the counter variable, and then it's gonna use the math verifier tool in order to generate the final answer. So this is the set of tools that the agent is expected to use. So once you define the user prompt and the set of tools that the agent expects, you have your evaluation dataset, which should look like this. And then all you need to do is creating a function that essentially it allows me to parse the output of the agent in a way that then I can pass the output to the evaluation framework in order to generate the evaluation metrics. So once you define this function, then you have everything you need in order to run your first evaluation job on Vertex AI. So you define an experiment name and an experiment run associated to the evaluation that you want to run. You define the metrics. In this case, we are gonna verify if the agent response is coherent with the input of the user. Plus, we're gonna see if the agent is capable of calling the set of tool in a specific order and matching also, the function name that is going to use. So once you define the metrics, you wrap the evaluation data set, the metrics, in an evaluation task, which is something, it's a method that we provide. It's a class that we provide. And then this class has an associated evaluate method that allows you to use the agent to run, it allows you to run the agent, generate the response, and based on response and the tool that the agent uses, calculate the metrics. So let's give it a run. It takes some time, but you will see that it will. What is happening behind the scene is per each user response, it generates a plan to answer that user request, and after it runs the request, the results of this request, so the tool and the response will be passed to the agent to calculate the metrics. So in this case, it generates the first response, and as you can see, this is the output that we are getting from the DeepSeek tool that we just initiate, and it will keep going to run this execution until it gets all the response from the tool, and once he has the response from the tool and the response generated by the agents, then it will start calculating the metrics. Now, I already done this. So while we are waiting, I can show you how it looks like at the end. So once you finish to run the evaluation, you will get a set of metrics in the left side panel, which essentially it's a panel that shows you all the experiments that you run. And here you will see the metrics that will generate. In this case, the response, the result coherent with the input that you pass to the agent. But for some reason, like the set of tools that we expect, it doesn't match with the set of tools that the agent generates. So it means that you need to tune a little bit better your agent in order to generate, in order to make him to choose the right set of tools. And at the end, like as you can see here, it's the output that you get from the evaluation. So you will get summary metrics that gives you an idea of how the tool works, and also you have a row-wise overview that tells you per each prompt how the agent performs. Again, like in this case, you can use this result, to evaluate how good is the agent. So at this point, you prototype your agent, you evaluate your agent. So now, how do you scale your agent? And that's why, Kris, I hand it to you to show how to cover this next step.
Yeah, absolutely. Thank you. I'll take over sharing from you, and we'll just talk about deployment for a couple of minutes, and then we will get to your questions. As a good reminder, if you have any questions, please post them in the YouTube chat, and we'll get to those in a couple of minutes. So, can you see my screen okay? Yvonne, you got a thumbs up? Does that look good? Okay, thank you. So we want to talk about, for just 1 minute, how do you deploy and scale? So thanks for that walkthrough, Yvonne. Now, when you build an agent, and an agent here is like a Python app or code that essentially runs an LLM like you see on the right, you really need to share it with the world. And it's not about, so when people think about scaling, the first thing they think is Google scale and scale to 1 billion users, but it's actually more about scaling hardware and cloud services. It's about making a reliable, impactful, and accessible agent to others. So a lot of people don't need to know about all of the details in your agent. So when you scale an agent, you need a set of services that lets you move from a local prototype to a remotely accessible service. And you need something, typically this is done with packaging, containerization, and deployment. And usually by the time you've built your agent and done the evaluation and you're completely out of energy, this is not the thing that you want to do next. But luckily, we've made it easy for you with a service called Reasoning Engine. And so this really kind of streamlines and serializes the process from I have an agent, I built it, it works on my machine. How do I share it with the rest of the world? So Reasoning Engine has templates for LangChain. We're working on LangGraph templates. And so it's something you can drop in, and you can find a lot of these code examples. We'll give you the link in a second. But basically, you do your development and your evaluation, like Yvonne said. Then when you're ready, you can use the Reasoning Engine SDK, which is inside of the Vertex AI SDK, to create a reasoning engine. And when you do that, it's going to package up all your dependencies, ship it in a container, and make sure that it scales well. Then you can query it from Python or a REST API. And at that point, you'll do a lot of management and monitoring, especially of the metrics that Yvonne pointed out, because without that, you're kind of just deploying new versions without any idea of the global impact of your changes. So in brief, you can look through the documentation, but I've bolded the important parts here. So you have a local agent, and you're wrapping up your local code. You then deploy that with Reasoning Engine. You then query that with Python or REST API. Now you can just drop in your agent wherever you need it, whether it's a customer-facing chatbot or some kind of autonomous backend process running. So really, with Reasoning Engine, and I'll show you in 1 second, is you get faster cycles, less burden. And really, it's, if I think back 10 years ago to when people were training and deploying models like data science models, deep learning, and I think about how Google Cloud evolved in that with Kubeflow and Vertex AI pipelines. This is very similar. So it's a very new and fast changing world. But the good news is we have the tools for you to do eval and deployment, so you can get back to working on your agent. And I'll just show briefly and you can look at these code samples and notebooks afterwards. But there's a short section at the end that talks about deploying your agent to Reasoning Engine. And I'll skip through this for time, but basically you test your agent locally. You can deploy your agent, which is going to package it up from your local environment, whether you're using Colab Enterprise, or your laptop. And it is going to ship and create this agent in a hosted way, like you might have a Cloud Run instance or a Vertex AI endpoint. At that point, you can call the agent from the Python application that it lives in, or some external application, maybe part of your web stack. So try that out. Deployment should take like 1 or 2 minutes. It's kind of fun to go from local to remote and then start building on top of that. So we'll drop you the links and resources to make that happen. So back to our presentation. So in summary, we wanted to show this kind of pipeline that we have, and you will get the code that Yvonne and I spend all of our days pushing code to our GitHub repo. We'll give you that link in a second. That has information about building models, building agents, doing eval. We have a lot of notebooks on eval, whether you're evaluating your prompts or your agents. So take a look at that. We'll give you the link in a second. And at this time, we'll jump over, and I think we have time for 1 or 2 questions. But thank you all so much for your time, and look forward to your questions. We will give you a link here while we pull up Q&A. It goes to our generative AI repo with 150 plus sample notebooks and such. So please grab them all, steal them, use the code to do really cool things like what Yvonne and I showed today.
Great, thanks, Kris and Yvonne for the great presentations. Yeah, we see a lot of questions. Let me pick a few. Let me share my screen. Okay, can you stop share your screen so we can?
Yep, you should have it control back now.
All right. Okay, so you can see my screen, right?
Yep, got it.
All right, so let me see. We have, all right, you can see the questions on the screen, right?
Yeah, absolutely. Yeah, I'll go ahead and grab the first one, Yvonne. I know you were talking a lot, so I'll give you a break. And so the first one, what is the difference between Vertex AI and Gemini AI? This is a very good question. We apologize for all the naming confusion. Yvonne and I live in developer relations, so we think about this every second of every day. Please keep the feedback coming. Long story short, there are a bunch of Geminis, right? There's Geminis everywhere. Google is a big place. But to give you the TLDR, there's the Gemini app, which you can see at gemini.google.com, or iOS or Android apps, kind of the consumer version. There's Gemini API in Google AI Studio. And so you can go search that out. Models come from DeepMind. It's very fast. And then usually within a few hours or days, things will then show up on Vertex AI. And Vertex AI has a Gemini API, but it also has a bunch of other stuff. It has storage, databases, networking, security, all the things you need to do all of this in an enterprise context. So that's the big difference between, so Gemini API is the large language model. It lives in a bunch of different places. There is a Vertex AI there is a Gemini API in Vertex AI that you can use, and that's what we're showing today. But great question. Thank you. Bill, how many more questions? You think 2 or 3?
We have a bunch
with your time.
We have
Okay,
quite
cool.
a lot, but
let's keep rolling.
Yeah, let me pick a couple of them.
Yeah, Ivan, you want to pick one off there?
Let me do that. So how do you position agent and the reasoning model such as R1? Will you use R1 to decide which function to call? Okay. So just to give you like an idea of a better idea of how the application that we show you today worked. So if you go on the DeepSeek R1 documentation, you will see that they explicitly say that the function calling is some capabilities that they are keep developing. So the things that I mean, I was thinking is that, okay, I cannot still use like these models to, doing function calling. So why not using it as a tool of the agent? So essentially the agent that we show you with Kris, he used DeepSeek R1, the clean distilled model to as a tool to evaluate math facts, but he used Gemini 1.5 Pro to orchestrate the usage of the tool and the agent itself using the Hugging Face Small Agent library. So this is how it, like just to give you an idea of how to use like a model like this one with agent as today. Of course, probably in the future they're going to release better function calling capabilities, so you can use R1 as an orchestrator of your agent as well.
Awesome. No, that's a great question. And Ivan, it reminds me of something I deal with in agent land when we're building. So we have all of these components like model, tools, function calling, prompts. And it reminds me that a lot of these are swappable and there's kind of an infinite amount of topologies, which is why eval is so important. So start simple, do eval, and repeat. It's a good mantra to follow. I think I've gotten stuck so many times on my 20 or 30th agent version where I'm not doing eval that it's a painful thing to do. But yes, let me. I'll throw this one to you, Ivan, for R1.
Yeah. So in the demo we used the distilled one. We used the Queen 7B model as a tool in the agent.
That's great. And one thing I should mention, it was in the presentation, but just in case you didn't catch it, Vertex AI Model Garden is a place where you can use Gemini models, Gemma models, Claude, and R1. So R1's available through Vertex AI's Model Garden, and you can spin it up. You get your an endpoint you can use securely. So when we talk about we're using R1, we're actually using it through Vertex AI, one of the many places that you can query these kind of models. But great, thank you, Ivan.
Great. Well, thanks. I think that's all what we can take for today, and we still have quite a lot of questions. But yeah, we need to move on to the next few speakers. Thank you so much, Kris and Ivan, for the discussions and presentations. I think there's some questions asked about some links, and you can share to me. I will share to the attendees after.
Yeah, absolutely. We'll be sure to get you the GitHub repo. I think that's the most interesting link to folks, and any other things we can share around evaluation and deployment. So thanks for having us, Bill. Thank you, Ivan, for walking us through eval. Appreciate it, everyone. Thanks for your time.
Okay.
Enjoy the rest of the show.
Bye-bye. All right, with that one, we're going to get ready for our next topic. Let me just quickly. Yeah, our next topic is DeepSeek on AWS by Suman from AWS. I will have Suman introduce himself and get started for the presentation. Suman, you can take it over whenever you're ready.
Sure. Thanks so much, Bill, and thanks, Kris and Ivan, for starting off this event by giving an overview of how one can use DeepSeek. Hello, everyone. My name is Suman Debnath. I work with the developer relations team as a principal developer advocate for machine learning at AWS. And today, what we are going to do is I'll not take much of your time, but maybe 15 to 20 minutes, and I'll show you how you can use DeepSeek on AWS. And not just for DeepSeek, but the idea that I have is you should be comfortable of using any model on AWS. There are different ways, and I'll just try to show you a few of those. And I will surely share a lot of resources that you can explore later on. So I'm trying
Sorry,
to.
Suman, sorry for interrupting you. Share your screen.
Yeah, I'm trying to share that. It is saying that sharing is not turned on.
Try it again.
Okay. It is still showing the same.
Okay, give me a second. Oh, okay. Hold on a second. Yeah, go ahead.
Okay, sure. 1 second. Okay, so let me know if you can see my screen. Can you see my screen?
Yet it's coming up. Yes, go ahead.
Okay, perfect. Yeah, sure. So what we're going to do is we are going to show you that how you can use DeepSeek on AWS. Now, there are different services that we have within AWS, but the foundational service or the fundamental service that one should use when it comes to large language model or foundational model is Amazon Bedrock. So before I come to this notebook, let me just quickly show you how that service looks like once you get into AWS console. So this is the AWS console. I've already logged in. You can search for Bedrock. And if you click here, you will come to this landing page. Okay, so here on the left-hand side, you will see a lot of different options. And what we are essentially concerned at this point in time is the foundational models here. And if you come to this model catalog, you will see models from different providers, and you can just use any of them and start working with them. So this is on the UI, and I'm very sure not everyone would like to work on UI, and that's why we will explore how we can use this model through API. Okay, so this is the service that we have where you can use any model from different model providers under the same API. So that's the flexibility that you get, that you just change one line of code and you can switch from one model to another. Okay, so there are different ways that you can use models on Bedrock. One of them is called import models, and the other one is custom models. So custom models are models which you want to fine tune. You can continuously pre-train and then deploy it. And the other one is import models. And this is what we are going to use to deploy DeepSeek. And again, this is just one way, and that is what we are going to talk today. But at the end, I will show you where are the other places where you can use the same DeepSeek model. Okay, so let's look into import models. Now, it's a very simple through UI, but we will go over the code that how you can deploy a DeepSeek model using model import. So we are going to use Hugging Face for this. And the reason that we are going to use Hugging Face is because we already have the model weights there, right? So we will leverage that. And all we have to do is we have to take those model weights, store it in some storage. In this case, it will be some object storage. And in AWS, we will be using S3. And once we store those weights, what we can do is we can create and import model job on Bedrock. That's all. It's just a two-step process. Download all the weights from Hugging Face, deploy it on AWS Bedrock. That's all. So first, we will install a few of the libraries that we would need, which is just the Hugging Face. hub from where we are going to download that. And then we are going to set few configurations or other variables. For example, we are going to store that model weights on S3. So we have to give the S3 path or S3 bucket name and all of those details that we would like to give. We will share it here. And also, since Bedrock need to talk to the model weights, which is stored in S3. We need to assign permission and write roles for the Bedrock to talk to our S3 bucket. So that's why we have to have an IAM role for this. So when you get this notebook, when you execute this cell, it will ask you for all these questions and it will have its default values. You just have to click enter, 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 and it's all done. So once you execute this, I've already executed this, that's why I'm not executing. But once you execute this, it will ask you for the repository ID of the model, which in this case is a Hugging Face repository. And if I have to show you, we can go to the UI and come to the Hugging Face website. And this is the model that we are going to use. DeepSeek R1 Distill Llama 8 billion model. So all you have to do is you just have to copy this and keep it in your clipboard and come here and paste it. So once you hit this cell, it will ask you for this ID. Just you have to mention the same model ID. That's all. So once you have all this set up, the next thing that we have to do is create those IAM roles. And you don't have to do it. It will, I mean, this code will do it. We have two wrapper functions, which will check your account ID. So this is assuming that wherever you are running this notebook, you already have the AWS CLI configured. That means your API keys, everything is sorted. So it will read from there. And if you are doing it completely on a new environment, you have to make sure that your AWS credentials are updated. That's all. So here we are going to create an IAM role, which I just talked about. And this IAM role will allow you to read, allow this IAM role will grant Bedrock to read data, or rather the model weights from S3 bucket. So this is just a wrapper code, nothing very fancy. And then we have one function which will create a S3 bucket in case you don't have any S3 bucket. I have already created an S3 bucket and I just gave that S3 bucket name in the previous cell when I executed that. So after all of this, you will see that it will create a role, a new role. It will also check if the S3 bucket exists or not. So this is the S3 bucket which I have already created. In case you don't have any S3 bucket, it will automatically create that. And that's all. So our first step is done. So we have created the S3 bucket, IAM role, and all this. So now the next thing would be to download those model weights. And this is where the Hugging Face hub would come into picture. And in this case, we are just giving the repository ID. And this repository ID is nothing but this repository, basically, right? The model ID which we have given. And once that is done, it will start downloading the model weights, right? So depending on the model, the size of the weights would vary. So this is an 8 billion model. If you use a bigger model, the size would be much higher. So before you run this cell, make sure that you have enough memory or storage, because I've seen that the model weights are pretty high if you are downloading any bigger model. So just check that. And the way that you can check it is simply if you scroll down here, I've seen somewhere. Yeah, if you come to this file and version, you will see what is the size of these models. If you see this, the size is roughly around 8 GB or so. Okay. All right. So once you download this model, you have to send this model weights to the S3 bucket. And we already have created an S3 bucket. So this function will just upload all your weights into that S3 bucket. That's all. And once this is done, it will show you which are the model weights it is uploading. And once this is done, you can go to the console and check that. So my model, my S3 bucket is this LLM weights demo. And inside that, you will see all these model weights. Basically, this is our model weights which have been uploaded on S3. So basically, what we have essentially done in this code so far in the notebook is we copied all of this and dumped it into S3 bucket, right? So we have not yet come to Bedrock, which we are going to do now. So at this point, we have everything. All we have to do is we have to import this model weights on Bedrock. And the way that we do it is just 2 lines of code. We use Boto3. Boto3 is the SDK to access any AWS resource from Python in your code. So you just have to import Boto3, and we create a client called Bedrock, and we specify the region. By default, it is US East 1, and that is the region that I'm using. And what we have to do is we just have to call this Bedrock object and call this function called create model import job. That's all. And I have to provide the S3 bucket location where my model weights are there. So this API expects you to give the model weights location. That's all. So once you start once you run this code, what it will show you is it will show you that the model job has started, and it will take some time because it will be importing the model weights. And once this is done, you will be able to see this job on your AWS console, right? So let me show you that. If I come to Bedrock and come to this import model and come here in jobs, you will see this job is getting started here. So at this point, it is completed because I've run this yesterday evening. But when you execute that code, you can always come here and check the status. It will show it's importing. Okay. So at this point, the model is not yet ready, but it is getting imported using the get model import job function, right? So we are just passing the job ID or the job ARN and reading the status, right? It's a very simple, straightforward process. Once that is done, you will get an endpoint, or basically the model ID, which is the deployed model on your AWS account. So once this is done, if you come to the UI as well and come to this models, you will be able to see the model. And this is the exact same ARN which we have seen in the notebook. Okay. So at this point, your model is deployed on AWS, and you can wait for a few more minutes because I've seen that even after deployment, it takes a couple of minutes to get it ready. So that's why this is just a safeguard, like just wait for 5 minutes. But you can skip that. This is just a precautionary measure. And then you can just use this model. Now, the way that you can use this is using 2 different APIs. One is streaming API and another is regular invoke API. So let's see how streaming API works. So streaming API is very much like when you ask a question, it will generate the tokens one after another, and it will show you the progress, right? So the output is will get streamed. And there is another API, which is just a model invoke, where you send the prompt and you have to wait, and it will give you the response in one shot. That's the only 2 difference. So basically, streaming API uses a byte object, which just iterates over and generates the data or the response. So this is again a wrapper function that we have created so that you can just send your prompt with your model ID. That's all. So you send your prompt and the model ID and the region, and what is the maximum number of tokens that you want the model to generate, right? So this is just for your own configuration. So when you look into this function, there is only one API. So this is very straightforward. You create a client called Bedrock Runtime. And this time it is Bedrock Runtime. Previously, it was Bedrock because that was a model import job, which is a control plane task. But here, it is specific to a particular model. So we are trying to invoke, send a prompt. So that's why the service name is a Bedrock runtime. So whenever you are working with any model, it will be always Bedrock runtime. But whenever you are working at a Bedrock level, like creating a fine-tuning job, checking the status of the fine-tuning job and all that, then we will be using the service name as Bedrock, right? So this is the only difference. And the API is this invoke model with response stream, right? And the other API, which we are going to see next, is just the invoke model, okay? So here, what we have to give is just the model ID and your payload, which is nothing but your prompt and other configurations like temperature, max tokens, and so on. And once you have this function, when you run this with your model ID and the prompt, you get the response. And this response, since I have executed this, you may not be able to realize this, but when you run this, it will run through, it will generate the output in a streaming fashion. Okay, so that's about streaming API. The other one is invoke model API, where you give the model and the prompt. But in this case, you just use invoke model, not the streaming API. So this was introduced first, and this was kind of people use it whenever they have to use it within an application. But streaming API is good when when you are building any chatbot or something like that, where you need to showcase the output to the client or the end application as it generates. So once you have this, you can get the same response, but in a different format. Like one is instant invocation, the other one is streamed invocation. So that's all about DeepSeek, or any model for that matter, when it comes to model import feature. Now, lastly, before I wrap up, I wanted to show you what are the different ways that you can deploy your model or use a DeepSeek model on AWS. So the other way is you come to this model catalog, and here we have introduced DeepSeek, and you can click on any of these distilled model. They all have different distilled model. So you can, if you want to see this, I think this is a better view. So you can see that there is 7 billion, 14 billion, and so on, right? So you can use any of these models from here and use it for in your application. Not only this, we also have a SageMaker service, which is meant for more data science or machine learning work. And if you use a SageMaker, in that case, this is the SageMaker AI UI. In this, if you come to a Jumpstart, which I have already opened. So the way that you can go there is come to domain. You have to create a domain. And after that, you click on this domain and launch this particular user profile. So you can create different user profile. That's how the SageMaker service is constructed. But the moment you click on Studio, you will end up coming into this UI. And here you can do a lot of things: train a model, fine-tune a model, etc., etc. This is more for ML practitioner. So here you see that there is an option called Jumpstart. If you click here, you will see a a DeepSeek. And if you click here, you will see all different models, same models, but you can deploy it through SageMaker as well. Okay, so there are multiple ways that you can deploy. There are other ways as well. You can deploy it on EKS as well. You can use Inferentia instances as well. So there are different ways that you can deploy. I will share you the blog post now, which will cover all these different options, how you can deploy. And I will also share this GitHub repo, which has this notebook, which we just looked into. And let me just quickly show you one more thing. So now that I'm speaking, if you are interested to learn this about me. So sorry for the brag, but I just introduced a new course, which is a free course, basically. I work mostly on multimodality and the fine-tuning side. So there's a free course on multimodality and embeddings. If you want to use it, or rather try this out, you may like to go over this. I'll share all these links with the blog and the GitHub repo and the course. And if you have any questions, feel free to ask. And if you don't have enough time, I'll be hanging around on the YouTube channel and I'll answer your questions there. But I'm just sending few links, Bill, to you. If you can share it on the YouTube, that would be great. Or else I'll do it once I leave this WebEx. Yeah.
Great, thanks. I think we have some questions. Let's take a few questions. Let me share screen. Can you stop sharing your screen? So let me share mine. Are you able to see the questions?
Yeah, I can. Our DeepSeek models are now available on Bedrock without needing import now? Yes, you don't have to. So if you use Jumpstart, you can use it directly from Jumpstart. But if you want to fine tune that or use any of the fine-tuned model weights, you can always use how we used today using Hugging Face. But you can straight away use that through Jumpstart on SageMaker as well as on Bedrock through Marketplace.
So another one.
Yeah, are there any limits for DeepSeek on Bedrock? Does AWS Bedrock allow fine tuning? Yeah, so we do allow fine tuning. There are different model families that supports fine tuning and model import. You can have a look. In fact, if I can quickly share my screen just for a second, Bill, if I can.
Yes, go ahead.
Okay, so if you see here, there is a model import, and you can import any model of these architectures, right? So Mistral, Llama 2, and all that, but not others. Similarly, if you want to have a fine tuning, you can certainly fine tune. This is for model import, but you can always fine tune any model of your choice. There are some restrictions around that, which are the models that base models that are supported, but you can check the documentation. But you can certainly fine tune Llama based models. Yeah.
All right, great. Thanks. I think we are out of times. Thanks a lot for the presentations, and I think there are some more questions. If you can stay in the YouTube channel chat to answer the questions.
Sure. Thank you.
Thank you so much. All right, so now let's move on to our next speaker, John Peck. John from GitHub. He's going to talk about the DeepSeek with the GitHub models. Hey, John, you can take it away whenever you're ready.
Well, brilliant timing. I think my audio just went out. Bill, can you hear me?
Yes, perfect. Clearly and loud.
Okay.
Go.
Thanks. That's what I get for the not charging my my earbuds early enough. So hey, welcome everyone. I'm John Peck, developer advocate for GitHub. One thing that I always try to do with any of my talks is make sure that you've all got a link to the slides. There's going to be references at the end, that kind of thing. So I'll show that URL that's in the bottom left a couple more times, gh.io/deepseek/models. And you'll be able to pull all of this as well as a whole bunch of learning links at the end so that we don't have time to spend time going over them right now. Anyway, I'm here to show you all about GitHub models. So GitHub models, we just added DeepSeek to this pretty much right after it came out. And what it does is it lets you test models against each other and then move directly from those into writing production code, right? And the cool thing about it is not only can you do that, you can test these out free. We've got a whole slew of models that are available there, but they all work initially when you're trialing them with your GitHub token. So all you have to do is go to github.com/marketplace/models. I'll keep that URL up a little while too. And you'll immediately be presented with this interface where you can just say, all right, what model do I actually want to start playing with? We'll jump into DeepSeek R1 because it's right there in the drop-down list. When you're there, you pretty much are presented with a space that gives you, first of all, on the right, a little bit of information about it, right? You know, what the purpose of the model is, what kinds of tasks it handles best, that sort of thing. There's a pop out there to more details and whatnot. But of course, on the left, you've got that interaction point where you can either pick one of the prefab questions that we have there just to test out, or you can type in your own thing. So I'm going to ask it about, say, the theory of relativity. Go ahead and hit that. And DeepSeek is immediately going to start giving me back information about, you know, about the question that I asked, right? We can see right there, it starts with the think prompt, etc. So this is cool, all right, but what I really want to do a lot of the time is I actually want to take a look at a model versus another model for my particular use case, which is where that compare button that you see at the top comes in useful. So as soon as I hit that, I'm presented with the option to pick some other model that I want to test this out against. And if I put in a prompt, it's going to copy that over into both windows, simultaneously go and execute that against both the models. So here I can just look head to head and say, hey, which one's better for this particular problem, right? One of the problems that we encounter when we're building applications is that we don't want to just do one size fits all, right? DeepSeek, better at that research and reasoning, etc. Other models, different, good for other things. Some are faster than others, etc. So I want to be able to take all my use cases, quickly dump them in, just try out different responses and see which one is performing better, both in terms of completeness of the answer and in terms of that time to first response and how long it takes to kind of complete all of its thoughts, because there's going to have different applications. Now, once I've played with them and I'm ready to start actually working at a code level, I can hit that code tab at the top, and that's going to give me, in whichever language I choose, the boilerplate code needed to call this model. Now, what's really cool about this is we actually support two separate APIs. There's the OpenAI compatible API for mini models. And then for others, there's this Azure AI Inference API, and that's available for all of the models. So you can start with either API. If you think you're going to be eventually moving to an OpenAI compatible service, it might be better to start with the OpenAI Inference API. But here I've selected the Azure AI Inference SDK. I think that's the only one available for DeepSeek right now. And this code will work regardless of which model I'm using. You can see right there, there's a line for model equals DeepSeek R1 right in there. And that is the place where I can just change that to literally any other model name that's available in the marketplace. The rest of the code is going to continue to work exactly the same. Now, the other thing to notice here is it's using OS environment GitHub token. When you're working in most GitHub environments, I'm going to show you something called code spaces in just a second, or if you set things up locally in a standard way, your GitHub token is already going to be present inside the environment. So that makes it really easy to just get started. You don't have to go and manually create one or anything like that. Later on, I am going to show you how you would go, and actually I think it's in the next screen anyway. So I'll just proceed to there. If I hit in the upper right, use this model, what that's going to do is first it's going to tell me, okay, if you need to create a token, here you can do that. Now, again, as I said, I'm going to be using code spaces for this. I'll explain what that is in a second. So I don't actually have to go and do this right now. But if I were going to be moving this code into some other environment where I wanted to use an explicit new token, not just my default personal token, I would just hit that Git developer key. That'll bring me to a screen inside GitHub where I can generate new tokens, and I can just copy those in. Of course, please use proper, secret sharing tooling. Don't just dump it raw into your code, except for locally. And then a quick note here, as I move to production, I'm going to want to move to a proper production key, and those are provided through Azure AI. Why do I need to move from a GitHub token to an Azure AI token? Well, that's because of the rate limits. So the free access we provide is going to have a limitation of either 15 or 10 requests per minute, depending on the size of the model that you're using, and 150 or 50 requests per day. So this is enough to get you started and playing with it and trying out those models and maybe writing some test code. But when you actually go and deploy it, that's when you go and you get Azure AI key. Again, everything else works exactly the same. Don't need to change any other code. You just drop in that Azure AI key so that you can pay as you go in your production app. All right, so moving back to that same screen where, hey, I hit use this model. It's telling me where those tokens are. The other thing I want you to notice there is in the lower left, that run in code spaces option, right? Now, let me talk very briefly about what code spaces are in case you've never seen them before. And I'm going to actually move out to live for just a second. My network is a little slow today, so I didn't want to do this for everything, but so that I can show you what a code space is. So I'm just in a random repository right now, one of my toy applications. I can hit code, and normally I'd be cloning this down, and then I would just be opening the whole thing up, setting up my local environment to work, et cetera, et cetera. But there's this very cool feature called code spaces in GitHub, whereby I can simply say, hey, code, open in a code space, start up a new one, or if I've got an existing one, go ahead and restore that. What that's doing right now is it's reading all of the information out of this dev container folder in my GitHub repo, Dockerfile, the JSON, it sets the environment, it sets the dependencies, it sets what base image it's using, etc. And what I get is I get VS Code running right inside the browser. This is fully functional VS Code. It supports all the usual extensions, etc. Later, I'm going to show using Copilot with it as an extension. But essentially, you treat this like you would any other VS Code instance. I can see all of my files that are in my repo. I've got a terminal down here. I can run commands. I can edit whichever code I want. It'll even, when I run it, stand up that instance in a protected environment that only I can get to, and I can open up another tab and I can see my web application. So this is really cool. What it's doing is it's running as a container in GitHub's cloud, and then it's providing information to that web-based instance of VS Code. Quick note, if you're running local VS Code or Visual Studio, you can also have that connect to the remote container, but I'm not going to go into that kind of detail right now. So to get back to our main track talk, what happens when I hit this run code space button is it does all that invisibly for me, because instead of pulling down code, setting up local, etc., which I could do, I've got the code sample there. Instead, this gives me one-click access to just simply start playing. It takes that sample code, it puts it into a new code space for me. It's got all the stuff I need. It's got, you know, a Python environment, it's got Node, etc. And it's got a whole bunch of sample code there for the different models and the different types of evaluations I might want to do. So without going into what all of the options are here, I've just opened up basic.py. I prefer to work in Python. And what I can see on the screen here is almost exactly the same as what I had before. It's getting that GitHub token out of the environment. Again, don't have to set it. It's automatic since it's a code space. And it's setting the model name down here. I'm just going to swap that model name out to DeepSeek R1. And then I'm going to go ahead and I'm going to run that basic sample just to see if it works. Go ahead, fire that off. Okay, I'm getting the response that I expect there on the console coming back from DeepSeek. So let's go a step further, because now what I want to do, I've proven that I can use it here, that it's working properly. And what I'm going to do is I'm going to start building my application. Now, when I build applications, I write raw code a decent amount of the time, but nowadays, 80–90% of the time, what I'm doing is I'm making use of Copilot. If you haven't used this before in VS Code, all you have to do is grab from that sandwich menu, go to View, and click Chat. If you're using an older version of VS Code locally, then you would go into Settings, you would go to Extensions, and you would search for GitHub Copilot and add that as an extension. Either way, what you're going to end up with is a Copilot window that you can see on the right-hand side. Now, what's Copilot? If you haven't come across it before, Copilot is an AI pair programmer. It does primarily two things, although I'm kind of simplifying here. But fundamentally, if I type a comment and I say, hey, I want to do some particular thing, or I start writing a function stub, or I'm in the middle of a function and writing a bunch of repetitive code, it's going to give me this ghost text prediction, which I can choose to accept or just keep on going and ignore it. That text, that ghost text that shows up is in most cases going to be more or less a complete function resolution to whatever I'm doing, right? So here, I said I want to determine whether the sentiment of a text is positive or negative, and I want to use a web service. It saw that, and it said, okay, here's one I know of that you can use. I'm going to give you sample code to call it, and then to evaluate whether or not it's a positive or negative response. Okay, I'll go ahead and accept that, and I'll move on with my day. The other thing it does is it provides this chat window interaction that you saw in the other screen. And in that chat window, I can do all kinds of stuff. I mean, I can generate new code, sure, and that's what I'm going to do here. But I could use it to highlight a bunch of code and say, give me documentation for this. Give me an executive summary and a bunch of function bullet points. Or I could take some code and I could say, I want you to write a bunch of unit tests for this. Or I could say, I want you to convert this from Python to Node for me. So it's pretty smart. It exists right there inside my development environment. So it's very, very frictionless to use. And in the GitHub tradition of providing a free offering for everything, we just recently announced GitHub Copilot free. So you can use this at no cost to you, get 2,000 completions per month and 50 chat messages per month. If you want to go beyond that, it'll give you a nag to upgrade to the Pro Edition, which is like $10 a month or something. Anyway, so here you go. And I'm just going to show you a little bit of using this now to build an AI-powered app. I'm going to keep it very, very simple intentionally. So you can see on the right there, I've just given it this simple prompt of build a Flask app, allowing me to type in a prompt and see the response, right? About the simplest application you could make out of this. You'll note, by the way, before I did this, I had that basic.py file open. So you'll see right below the red arrow on the right, it's saying basic.py and what lines it's looking at. It's letting me know that it's aware of what I have open in terms of code and what I've selected specifically in this file. So when it responds to this request, it's going to use that as part of the context, basically part of the prompt that it sends out for the prediction. So I say, okay, I've got some sample code for going and calling an AI service. Now, hey, AI Copilot from GitHub, I want you to help me build a Flask app using this as an example. And when I hit that, it actually begins generating an entire skeleton, right? Not just a simple single file response. It's actually saying, okay, I'm going to create an app. Here's my init.py. Here's the routes I'm going to set up. I'm going to give you a default template. I'm going to set the requirements file because you're going to need that for the inference portions. And it even creates a README for me. So that's all pretty cool. I say, yep, that looks good. I could go and inspect those, but I'm just going to hit create workspace. And then it goes and it does that. And here we go. I'm taking a look at my routes py that it just created, where it pretty much does what was in the basic py, and that it's going and it's getting the GitHub token. It's setting that endpoint that it's going to infer from. It's setting the model. But then, of course, it's going in and it's actually creating a web app, which is going to respond to a GET or a post when I go out to it. And it's going to give me this form and all of that kind of stuff. Long story short, if I go ahead and I run that, just type Flask run, you'll see it fires it up. It opens it up on localhost. Of course, keep in mind, this is localhost on that remote machine, right? So it's got a funky URL, not actually running on my 127.0.0.1 locally, but it gives me a little pop-up there that says, okay, if you want to see that, go ahead and open it in a browser. I click that, and there we go. I've got my actual application running. It has a way for me to type in a prompt and get a response from the model. So hopefully this has shown you how to go very quickly from, hey, I want to start playing with DeepSeek, to I want to compare it with other models, to I actually want to build in real time an application that goes ahead and uses it. With that said, once again, these are all available for you. gh.io/DeepSeek/models. Those links should be live, and I'll add some more references at the end for learning after the fact. You'll see those update in real time. Bill, do we have any questions that have come through?
Yes, yes, absolutely. Great. Let me bring up the Q&A. You can see my.
You probably need me to stop screen sharing, don't you?
Okay.
Cool.
Let me see. I think we have one here. Give me 1 second. I have see the question. I ever see the questions on screen?
I do not, but that's because I'm on the wrong tab. There we go. Okay, how is DeepSeek R1 compared to a reasoning model? Like, I've only used DeepSeek itself a little bit. My biggest experience so far is just that it takes a really long time to get through Think. I love having all of that output, but most of the time right now when I'm building applications, I want something that optimizes for the, fastest first byte that I can actually get back out to the user. And so I think DeepSeek R1 is really great in interactive mode when you want to see what it's doing and you want to see how it's thinking through a problem. But more often, I'm actually going for smaller, faster models right now for the applications I'm building, because those are usually at this point in time just things that are very simple. Hey, I want to use generative, right? So actually, if you could give me back screen share for 1 second, Bill.
Sure, go ahead. Let me see. Go ahead.
Cool. So here's one example, simple little app I'm working on right now. It's creativecradle.com. And what this is it's a domain name finder, right? So I can type in something like I'm selling oranges in Seattle. Okay, whatever. And it's gonna be able to filter by what domain names, what TLDs I want to use, etc. And it's gonna go out and generate a bunch of domain names, and then it's going to give me just the viable ones as results, right? And you can see right now, it took a little time to think. And what I want to get to here is that an example like this, right? What I actually have to go do is I have to go out, I have to hit a model. I have to say, hey, based on this prompt and some other sweetening I've put in there, I want you to be creative and generate a whole bunch of names. And then I've got other work to do on the back end, making sure they're valid, that they're not currently registered, they're not currently on auction, etc. Right? And all of those things as individual calls, even though I'm parallelizing them, each one takes a little while. And so a model that's going to respond to me in half a second and actually start feeding me back things that I can then use asynchronously to go start pulling domain names and validating them is much, much more valuable to me right now than a more powerful model that is going to give me a complete thing, but in a web application, users aren't going to sit through a 15 or 20-second latency. That said, I think for especially research purposes, DeepSeek is going to be really, really huge. And what I'm seeing right now as the major horizon for those is really going to be tools for researchers, whether that's science or whether that's market research or whatever. I actually see it as much more of an interactive model. Sorry, long-winded answer to a simple question.
All right, great. So we have our next questions.
Oh, limit on context in GitHub for a repo. I have to look at our latest models. And it does depend what version of your Copilot plan you are using. So Copilot comes in, the free tier, and then it also comes in both the pro for individuals and then also business tiers. And the context size varies with each of those. Off the top of my head, I believe it is 64K for Copilot free and 128K for the higher tiers. But That's just off my memory, and it's changing, every couple of months at this point.
All right, let's get to the next questions, which is the last questions we're going to take.
SDK support for DeepSeek. So there is, at least on the GitHub models page. It has to be the Azure SDK, not the OpenAI compatible SDK. So that's the only limitation there. And I think that just has to do with, on the back end, how it's hosted right now. If somebody has built an OpenAI port for it, I'd love to know, because then I'll just send that to my team.
Awesome, great. Thank you. Thanks so much, John, for the presentation and the Q&A discussions. Great. You're going to send me those links, some of the resources, and I can share to the attendees post events.
All right. Have a good one. Thank you.
All right, great. All right, so our next speaker, Laurie from LlamaIndex. Let me hold on a second. Let me set you as a co-host. All right, so Larry, I think you can share your screen.
Yep, looks like it.
Yeah.
Oh,
Yeah, you can go ahead, get started.
all right. Hi, everybody. My name's Laurie. I am VP of Developer Relations at LlamaIndex. In a former life, I co-founded NPM Inc., so some of you may know me from then. I used to talk incessantly about JavaScript. Now I talk incessantly about AI. The common thread is that I talk incessantly. Today, I'm going to be talking about LlamaIndex, starting with what it is, and then we're going to talk about agents, what they are, how they work, and how to build one, including building a multi-agent system. And then we're going to move to RAG, the most powerful tool that your agents can have to work with data. And to wrap it all up, we're going to see how all of this works with DeepSeek, which is what we're here to talk about. So, what is LlamaIndex? It's a bunch of things. Let's start with the most obvious. We are a framework in both Python and TypeScript that helps you build generative AI applications. Today, we're going to be working in Python, but our frameworks aren't all that we do at LlamaIndex. LlamaParse is a service from LlamaIndex that will parse complicated documents in any format, so PDF, Word, PowerPoint, that kind of stuff, into a form that can be understood by an LLM. This is critical for lots of Gen AI applications, because if your LLM can't understand what it's reading, you'll get nonsense results. LlamaParse is also free to use for up to 1,000 pages a day, and it will demonstrably improve what your app can do. Then we have Llama Cloud, which is our enterprise service. If what you want to do is stuff a whole bunch of documents into one end and run retrieval augmented generation on the other end without having to think about all the stuff in the middle, then this is the service for you. Unlike the rest of LlamaIndex, it costs money. It's available as a SaaS at cloud.llamaindex.ai. Currently, there's a waitlist to get in, or you can get it deployed to your own private cloud. And that is the end of the plugs, I promise. We also provide Llama Hub, which is our registry of helper software. If you need to connect your LLM application to any database in the world to get your data, we've got you. We can get your data out of Notion or Slack or Salesforce with no problem. If you need to store your data in a vector store, and you probably do, we support them all. And you can connect to OpenAI, to Anthropic, to DeepSeek, of course, or some other LLM. We support over 30 different LLMs, including local ones like Llama 3. And if you want to build an agent and you want some pre-built agent tools, we have dozens of agent tools already built for you. But why should you use LlamaIndex? Because we will help you go faster. You are a developer, you have limited time, you have actual business and technology problems to solve, so don't get stuck figuring out the basics. With LlamaIndex, you get to skip the boilerplate, you get to avoid early pitfalls, you get a bunch of best practices for free, and you get to production faster. But before I start talking about how to build agents, I should define what an agent is. It's a term that is dramatically overused in the industry to the point of being meaningless. But when I use it, what I mean is semi-autonomous software. You give it a goal and a set of tools, and it uses an LLM to decide how to achieve that goal and what to do with those tools. Agents are a dramatic departure from traditional programming, where you define exactly what's going to happen in what order. In an agent, LLMs are given decision-making power. In December of last year, Anthropic did an excellent post that everyone is citing about how to build agents. It drew on their experience of building agents and formalized 5 core patterns that we very much recognize from our own work on agents. Those are chaining, routing, parallelization, orchestrator workers, and evaluator optimizers. What I'm going to be doing today is showing you how to implement those agentic patterns in LlamaIndex and explaining what they are to achieve fully capable agents. The first and most obvious pattern is the chain. If you use an LLM to do some work and you pass the output of that LLM to another LLM and so on to complete a complex task, you're building a chain. It's trivial to build a chain, especially in LlamaIndex. The building block of agentic programming in LlamaIndex is the workflow. Workflows are a flexible event-based pattern that you can see here. Workflows are a series of steps connected by events. You use the step decorator to define a step, and you use type annotations to indicate what events should trigger your step and what type of events it emits. LlamaIndex workflows have a built-in visualizer, the output of which you can see here. This is obviously a chain. You can use the events to pass data from step to step and then return the result with a stop event. But there is much, much more to LLM applications than the chain, despite what the names of some other frameworks might indicate. The next pattern Anthropic called out is routing. In this one, you create several LLM-based tools to solve a problem in various ways. And you give an initial LLM the choice of which tool to use. Again, this is not that complicated a concept. And it's simple to build in LlamaIndex. In workflows, you do this using branches. Instead of returning a single type of event, you can define your step as returning multiple possible types, and you can use logic inside your step from the LLM to determine which to return. This allows you to create branches, which can in turn then have their own chains as visualized here. I'm going to spare you the code. The next pattern that Anthropic talked about is parallelization, and this is where things get more interesting. Anthropic defines this as running several LLMs in parallel and aggregating their results. They define parallelization as having 2 flavors. The first is what they call sectioning. This is where you take the same input and act on it in completely different ways. An excellent example is guardrails. In one track, for instance, you can ask the LLM to answer the user's question. In a separate track, you ask the LLM to scrutinize the question to see if it's asking to jailbreak or do something illegal. This allows you to preempt the output and cancel work before you output something dangerous. And you can do it in parallel because those, the answers don't depend on each other. It's not a chain. You can do those things separately. The other flavor of parallelization is voting. This is where you give the same task to different LLMs, for instance, and you see if they all come up with the same answer, or you phrase the same task differently and give them to the LLMs. You can then take a unanimous vote or a majority vote, and you can use it to reduce errors and hallucinations that way. If more LLMs give the same answer, it's more likely to be accurate. Whichever flavor you use, it's implemented the same way. LlamaIndex allows you to do this by emitting multiple events simultaneously. This will trigger multiple steps to execute concurrently. And then we have a utility function called collect events, which will aggregate the resulting responses and allow another LLM to act upon them. And of course, your parallel calls can have their own chains and their own branches. You can see how things begin to get complex and why it's great to have a visualizer. The next pattern is orchestrator workers. You can use an LLM to look at a complex task like a multi-part question and split it into several simpler questions, then ask each of those questions in parallel. You then collect all of the answers and get another LLM to synthesize a single response that answers the full complicated question. In LlamaIndex, this is implemented pretty much the same way as you implement sectioning or voting. You just process the collected output differently. You can obviously combine all of these patterns, and in LlamaIndex we do. One of our favorite combinations is a multi-agent workflow. You create multiple agents, each with their own specialty, and of course they can have chains and branches and concurrency, and you get them to hand off tasks to each other depending on the specialty. We first encountered this in a customer service application where users could have many types of questions, and dividing and conquering in this way was very useful. I'll talk more about multi-agent systems in a bit. The final pattern Anthropic called the evaluator optimizer. It's also called self-reflection. In this pattern, you use the LLM to decide whether the LLM has done a good job, and you can give it a chance to try again, optionally with feedback that might help it do better. This is, again, easy to do in LlamaIndex. You simply create a loop. In this case, you can see in step 1, it's a loop that loops back on itself, but you could go many steps of chaining down before deciding to loop back to the start event. And you can use that loop event to send data back to the initial steps saying, hey, things didn't go so well, here's something you might try. The real power here is obviously combining all of these patterns. You can create arbitrarily complex workflows to handle any combination of circumstances. But right near the beginning, when I was defining an agent, I said it was about the ability to use tools. And so far, we've only discussed that in the abstract. Here's how you actually do that in LlamaIndex. Tools are just Python functions, and you wrap them in a tool description. LlamaIndex uses the docstrings and the function name and the arguments to the function to tell the LLMs what the tool actually does and how to use it. What you do once you've got a tool is you give it to an agent, literally by just passing in an array of tool objects. LlamaIndex currently has 2 built-in agent types which accept tools. One is the React agent, which works with every LLM, and the other is the function calling agent, which works with the more capable ones like OpenAI, Anthropic, and of course, DeepSeek. This allows you to create workflows that are multi-agent systems. You put as many agents as you need in as many steps as you need, and you connect them with events. It's simple and it's elegant, and our users like it a lot. In fact, multi-agent systems are such a popular pattern that we created a shortcut to building your own. It's called the agent workflow, and it's built on top of workflows, so you already know how it works under the hood. You use it by creating as many agents as you need, such as the one that I'm showing here, with as many tools as that agent needs. So you give it a name, a description, you give it a system prompt, you give it an LLM to work with, and you give it that array of tools to work with. And then here in what is technically a single line of code, you instantiate the agent workflow itself. You give it an array of agents that you've created, and you tell it which agent to start with. And then you give it an initial state of the world, and your agents can take it from there. They will use their tools, they will pass back and forth between themselves, and they will attempt to complete the goal that you've given them. So now you've learned about workflows and agent workflow. That was a very lightning tour. There's a lot to take in there. So don't worry, we have a step-by-step tutorial about how do you build workflows and how to use agent workflow. It's available at this link. And I will have a link at the end that will get you back to all of these slides, so you don't have to get that link down now. This tutorial is very quick. It should take you like half an hour to get fully up to speed. When building a multi-agent system, like I said, one of the most useful tools that you can give an agent is access to your data. LLMs are trained on mountains and mountains of data, but they are not trained on your data. So to answer useful questions about your data, you have to give them your data. This immediately runs into a problem with LLMs, which is that you have a lot of data, and even the very best LLMs can only accept maybe 1 million tokens worth of context. You have much more data than 1 million tokens worth of context, so you have to be selective about what you give them. You have to choose the most relevant data, and that brings us to retrieval augmented generation, or RAG, which is the technique that LlamaIndex is famous for. RAG provides your agents with effectively infinite context. The way RAG works is you take all of your data and you pass it through a technology related to LLMs called an embedding model. This converts your strings of data into arrays of numbers called vectors. And these vectors represent the meaning of that data. The total set of possible vectors is known as vector space. So what you're doing is known as embedding them in vector space. And the results are called embeddings for short. Then, when you get a query about your data, you pass the query through the same embedding model, and through the magic of semantic encoding, your query ends up mathematically nearby in vector space to the data that is most relevant to answer that question, because the meaning of your question and the meaning of your data are similar. So you retrieve that relevant data and you pass that data and your query to the LLM, and it generates an answer. Hence retrieval augmented generation. Let's talk about how you build a RAG pipeline in practice. First, an overview. You ingest your data from wherever it lives. You parse it into smaller chunks. You run those chunks through an embedder, and you store them in a vector store. Then you use a query to perform semantic search on the chunks that are in your vector store. You take the chunks that you retrieve and pass them to the LLM with the query. And the LLM generates a response to the query based on the data that you gave it. Now let's look at how you achieve each of those steps in LlamaIndex. First, you need to get your data from somewhere, whether it's the file system or a database or an API. Our connectors will do all of that for you and turn them all into compatible document objects, so you don't need to figure out how to make them interoperable. The next step is parsing. We have a bunch of built-in parsers that you can use for free. They are open source, but the real secret weapon is LlamaParse. It is going to take documents your LLM can't understand, like Word docs, PDFs, PowerPoints, Excel sheets, and turn them into data that your LLM can actually use. Next, you have to embed your data. You can use third-party APIs like OpenAI to do this, or you can use local embedding models downloaded from Hugging Face. We'll see that in a bit. We provide a simple one-liner that does that. Once your data is embedded, you have to store it in a vector database. We integrate with every vector database that exists, so you don't need to learn all of the different APIs. We take care of that for you. To use your embedded data, you need to query it. LlamaIndex will embed your query, find relevant chunks in your vector store, and return those chunks. You can then do all sorts of stuff to those chunks, like applying a re-ranker to further improve relevance. Your retriever is completely customizable. And then usually what you do with the relevant chunks you've retrieved is you send them to an LLM along with your query. There's lots of ways to do this, and we do all of them. We'll give you a query engine and take care of it for you. And of course, we don't just do this stuff for text. We can do it for images as well. You can embed image data. You can query it by other images, and you can retrieve relevant images. In LlamaIndex, building a RAG pipeline, like I just described, is just 5 lines of code. In the first line, we're using LlamaParse to load and parse the data. This is optional, like I said. We have totally local options as well. Then we embed and store the resulting documents. This uses OpenAI by default, but you can use anything. And then you turn your index into a query engine, which is the part that actually does RAG. You query it and you print your response and you're done. Of course, that's very simple RAG. In reality, RAG has trouble answering some kinds of questions like summarization, comparison, and multi-part questions. To address those issues with RAG, you use the techniques that we were discussing earlier. You use agentic techniques. Patterns like routing, orchestrator worker, and evaluator optimizer were specifically designed to address those limitations. RAG is a super powerful tool, but you don't use it by itself. You build it into a larger agentic strategy. Why is summarization a problem? It's because RAG is designed to select a subset of your data, but summarization requires, obviously, all of your data. The pattern to use here that we discussed earlier is routing and parallelization. When you see a question about summarization, you don't route it to your regular RAG pipeline, you send it to a summarizer. That summarizer can split up your whole document, summarize each of the chunks, and then aggregate them into a single summary. Ideally, you do that just once in advance rather than every time somebody asks for a summary. Comparison tends to fail in RAG because it tries to retrieve chunks about all of the things you're comparing all at the same time, and then it gets confused about which chunk is about which thing. A parallelization strategy here is obvious. You ask questions about each thing and then compare the answers at the end. And multi-part questions fail because RAG is good at getting context for one question at a time. As we saw earlier, you solve it by using chaining and or parallelization, to split up your question into many simpler questions and answer them separately. So we've learned all about agentic strategies and how to build them in LlamaIndex. We've talked about tool use and the particularly powerful tool called RAG. Now, how do we do all of that in DeepSeek? Drum roll, please. I'm afraid that's it. Sorry to disappoint you after all of this buildup, but using DeepSeek is just a matter of one line of code. You install the DeepSeek API using that pip install line, and then you instantiate an LLM. You pass that LLM into your agent, or you pass it to your query engine if you're doing RAG, or both. If you're doing RAG with DeepSeek, you do need to do one extra thing, because remember, you have to embed your data. DeepSeek, unlike OpenAI, does not provide an embedding API. So you can either use OpenAI's or you can use local embeddings. This is the one-liner that we use to create a local embedding model. We're using Hugging Faces models. And then you pass your embedding model to your vector store index. And then your RAG will work completely locally without using OpenAI at all. Of course, this is assuming you're using DeepSeek's own API, but DeepSeek is open source, or at least open weights. So that means that you can find it hosted in a ton of other places. You've seen some of those this morning. Here's a list of other hosting services that provide DeepSeek. We have integrations to all of these, plus others that I didn't have time to research. DeepSeek is great. It is an exceptionally powerful model, and using it in LlamaIndex, it's a snap, as you've seen. What's next is up to you. We are excited to see what you can build with all of this. We welcome feedback from the open source community, which means you. Join our Discord using this link to ask questions of your peers and also our engineers who hang out there all day. We also have extensive documentation that I've personally spent a ton of time writing, so we welcome feedback on that too. All of the slides that you've just seen with all of the links that you've just seen are available at this link or this QR code. I hope this has been a useful introduction to LlamaIndex and all that it can do, but also the wider world of agents and retrieval augmented generation. It's been a pleasure to speak to you, and thank you all for your time and attention.
All right, great. Thanks, Laurie, for sharing the LlamaIndex and the agents, and also DeepSeek, of course. I think we have quite a few questions. Let me bring up the questions. Just give me 1 second. All right, so do you see the questions on screen?
I do.
Okay, cool.
So we differentiate from LangChain in a couple of ways. One is our greater breadth of data connectors that reflects our basis in RAG. Our second is workflows. Workflows are, we believe, a significantly more ergonomic way of putting together the sort of agentic patterns that we were talking about. LangChain's approach is graph-based, which has some limitations that they are currently trying to work around, and we think that workflows don't have those limitations.
All right, next one.
The advantage of LlamaIndex over CrewAI or Amazon Bedrock, those are two quite different things. So Amazon Bedrock is a service that we integrate with at LlamaIndex. So that is you would use them at the same time. CrewAI is a very high-level framework for producing multi-agentic systems. For our own, we think that the ability to drop down into workflows to produce more precise control of your multi-agentic system is our differentiator over CrewAI.
All right, we have another one.
Some scaling issues for productionizing multi-agent systems to large traffic. That's an excellent question. There's all sorts of places that a multi-agent system can run into scaling issues. Where we personally run into it is just the traffic limits to the upstream models themselves. We use hosted models, and they only have a certain number of queries of tokens per day, and we run into those all the time. Other than that, a workflow-based system allows you to efficiently parallelize your queries such that you can get around quite a lot of scaling issues.
All right, let's take one last question.
So can you help the most an agent orchestrator to select the right tools agents? Sometimes the transfer to agents is not as smooth as expected, even more in a long sequence of tools that should be called in sequence. That is an excellent question. That is exactly why we created workflows, because workflows allow you to very precisely specify how data can pass around your system. So your workflow can say, okay, this agent should only talk to these two other agents. These two agents can talk to this agent or this agent. You can be very precise about where the data can go in your system. So when you want the flexibility of a multi-agent system where the agents can call any other agent, you can do that. But if you have a more specific flow that you have in mind, workflows are perfect for defining that chain of events.
Awesome, great. I think we are right on time. Thanks, Laurie, again for the presentations and the discussions, Q&As with our audience. It's great. I think I have you have those links for the slides. Some of the links you can later you can share to me. I can share to the attendees.
Will do.
Great, thank you so much. And we are going to move on to our last speakers for today. He come from Vectara and actually his topic going to be a little bit different from the previous speakers. And I think he's going to talk about the hallucinations, even for the DeepSeek R1 or V3. I think without further ado, let's welcome Ofer.
Hi, everyone. Can you hear me okay? Okay.
Yes. Give me 1 second. Okay, go ahead. You can share your screen.
Great. Thank you. Let me share my screen here really quickly. It's this guy here. All right. So welcome, everybody, and thanks for all the other speakers so far. Really interesting perspectives on DeepSeek and how to use it in various scenarios. As Bill said, my talk will be a little bit different. I'm going to talk about hallucinations. And the reason I'm going to talk about this because it's interesting and it's still one of the most difficult problems for enterprises to solve when applying LLMs to different generative AI use cases. So a little bit about myself. I'm Ofer. I run developer relations at Vectara. And you can see if you want to connect with me, I have the links here. And I have a lot of experience in the world of LLM. I got fortunate enough to start working on LLMs around 2019 when GPT was just turning 2. So it's been really interesting to see the progression of that over the years. And when we talk about hallucinations, a lot of people focus first on the hallucinations of the pure LLMs. Like you ask, this is one of my, a little bit dated, but one of my favorite examples of maybe a year and a half ago, if you ask ChatGPT 3.5 or 3.5 Turbo, this question about Will Smith, that's the answer you got verbatim. And we all know what really happened, which is this in the Oscars, right? So we all know LLMs hallucinate. And one of the explanations of why they hallucinate, there's a lot of a lot of explanations that people provide. This is one of the ones I wanted to share today. Is essentially, if you think about it, LLMs train on trillions or even hundreds of trillions of tokens, and their models themselves are much smaller. They're in billions or tens of billions or even hundreds of billions of parameters. which is often like 100x to 1000x compression ratio if you think about it. And so by definition, it has to be lossy. It has to lose some information. And so you think about the space of the training set and the space of what is captured by the LLM. And because LLMs are completion engines in a sense, they look at the next token. They try to complete with whatever they have in their knowledge base. And when they don't know, when the information is not sort of adequately represented in their world model, they hallucinate. They make something up. All right, so and we know hallucinations remains a pretty big problem, especially for adoption in enterprises of generative AI. This is an example of an article from Fast Company just this last Thanksgiving, but there's examples of this all over the place, and they kind of reduce the trust that people have in deploying these these models. So that's why at Vectara we focus a lot on hallucination reduction, and things of that nature. So one of the things I wanted to show today is the hallucination detection model, or HHEM. It's a model that is trained just to detect hallucinations. So that's if you're a machine learning engineer, it's a pure classification model that just detects hallucinations very, very well and very, very fast. There's an open source version. It's available on Hugging Face, and you can see it's just passed a month or so ago the 3 million downloads on Hugging Face. So it's by far the most popular model for hallucination detection. And then at Vectara, we provide a commercial strength version of that. There's also multilingual. So when you call Vectara RAG service, you get the response, you get the citations and everything you would expect, but you also get this HHEM, we call it the FCS, factual consistency score. And that's a better version a little bit of the open source. And it also supports other languages other than non-English, but that's a very popular model, and you can find the open source on Hugging Face here, and download and try it yourself. How do you try it? This is on the website there, but just to show you here, it's very simple. You get sort of the context or the things that you want to have as your kind of your sources, and then the summary or the generated summary. And here's like 4 examples. And you can use it just with Hugging Face. You sort of load the model directly from Hugging Face, and you just predict, and that's it. You get those hallucination scores between 0 and 1, as we can see here. So the nice thing about this model is that it's very quick. It's like 100 milliseconds or something. It's not an LLM call that could take 4 or 5 seconds at best, and it's free. You can use it anytime you want. Now, the other thing that's interesting is we created this model probably about a year and 2 months ago or something like this. And we realized that this is actually really helpful to measure how much LLMs hallucinate. And this is the current or almost up-to-date version of this HHEM leaderboard we created, that over time we add new models to it and measure their likelihood to hallucinate. So you can see this leaderboard. It's the propensity to hallucinate, and it's really helpful to choose which LLM you use based on this hallucination rate. Again, you can see the leaderboard on Hugging Face, and it's a lot longer than this. It's just that's what I had space on the slide for. The other interesting things here are, in addition to the hallucination rate, is the answer rate. So, of course, an LLM could be kind of cheating by refusing to answer like half of the questions and only answering the ones that don't hallucinate. So when you look at this, look in the context of sort of the answer rate as well. Okay. So does DeepSeek hallucinate? Well, that was our big surprise. So we added DeepSeek about a week ago, or a week and a half, to the HHEM leaderboard. And to our surprise, it hallucinates a lot more than its sort of the other DeepSeek models, V3 and V2.5, which are non-reasoning models. They're not like trying to do reasoning. And so That's a big hallucination rate, 14% of the cases. So therefore, we currently believe that it's not such a good choice for RAG or agentic RAG because of that reason. And I'm gonna show you a little bit of what's been discussed in this blog post we posted right after we made this discovery, but I wanted to save you some of the time reading it, although you can read it afterwards. But just going through a couple of more details about this. This was again a big surprise for us in the Vectara ML team. We kind of didn't believe it at the beginning, but we did some validation, and I want to share that with you. So first of all, when you look at DeepSeek, and we just used V3 just to make it simple instead of going back to the older model 2.5. But if you look at DeepSeek with HHEM, you see a big difference. So the non-reasoning model, V3, is, it's not the top of the chart, but it's pretty decent. That's a pretty decent hallucination model. But then this one is pretty big. But we also looked at Google released this another hallucination detection leaderboard called Facts, and it uses an LLM, not a model like that. And we still saw that, even just to validate, we saw that even with their approach, which there's some criticism for, but even with their approach, it's again consistently higher with 3 different techniques that can be applied there. So the conclusion is that yes, R1 hallucinates more than the V3 across all the measurement approaches, as you can see here. Now, why does HHEM show a larger gap, right? We see that this is 14% and this is higher, but not that much higher, right? And so there's a lot of other criticisms on the web on using LLMs for these kind of tasks. So that's one thing. But we also looked at sort of all the examples that we had and measured sort of the mean and the median and the standard deviation of the hallucination scores. And what we discovered is that, yes, DeepSeek is higher on both the mean and the median, but its standard deviation is also really, really small. That's the sort of the error bar around those scores. And so based on that, kind of the hypothesis we have, which we're still evaluating, is that DeepSeek R1 produces many more samples that are borderline hallucinated, not like extremely hallucinated, but just borderline, than V3. And HHM is able to kind of find those cases more easily, and that's why it increases the hallucination rate so much, whereas the LLM approaches do not. Okay. So this is kind of I put together this table to say, well, is this applied to all reasoning models, not just R1? Well, it turns out that's not always the case. And so since we published this blog post, OpenAI also released O3 Mini. There's a low, medium, and high reasoning. And so when you evaluated this immediately took over the first place with 0.8%, which is an amazingly low hallucination rate. And a couple of days later, Google Gemini released their new Flash 2.0, which is 0.7, which took over the first place as well. So it doesn't necessarily mean that, especially with the O3 Mini, that things need to be worse. We don't know what exactly DeepSeek did in that sense to reach that high of a hallucination rate. And I'm personally pretty confident that they'll fix that soon. But at this point, it is kind of high. Here you can see the reasoning model from OpenAI. So reasoning does not necessarily need to mean that you have low hallucination. You just have to care about it when you train your model and make sure that it doesn't happen in this way. All right. So that's my slide. Just wanted to say, a little bit about Vectara. For those of you who don't know, we're a RAG as a service. So we have a full platform of models and steps. So instead of building the RAG yourself, you can use our platform through 2 simple APIs, one to upload your data and one to run queries or chats or agentic RAG or whatever. And we have all the components inside, so it makes things faster, more efficient, and more easy to maintain. The system is available on the cloud, but also can be, of course, on your VPC and on the premise. And that's all I had. If you want to try the Vectara, there's a QR code here, or you can just go to this URL. If it's a developer platform, so I put a link here for our documentation of the API. Join us in our Discord server if you have further questions for me. I'm there. I'll answer some questions now, but if you have other questions we don't get a chance to, you can ping me on our Discord server or just contact us for more information. And thank you for listening.
Great, thanks, Ofer. I think we have some questions. Let me bring up the Q&A. You should be able to see the screen, right?
Let me stop sharing and then I can probably see. I can't see it.
Hold on a second. Can you see the screen? Different tab? Okay, let me try again.
I'm sorry, I don't see the screen. I see you.
No, that's fine. Give me a second.
Yep.
Give me a second. All right. Are you able to see the screen?
Yes.
Okay, good. Okay, let me bring up the first question. I have a few questions here. Give me 1 second. Let me see. I'm not sure if this question is for the previous speaker or for you, but you can take a look at it to see if it's relevant to you.
Yeah, I can try to answer that. So yeah, I think workflows is maybe specific to LlamaIndex, and thanks, Laurie, for detailing this. But generally, I would say the question is workflows are kind of semi-autonomous and agents are fully autonomous. How workflow serves the purpose of in your framework. So we have a framework called Vectara Agentic to build agents and agent workflows with Vectara. It's a little bit of a higher level framework that makes it easy to build very quickly and connects very easily to Vectara. And the same concepts of workflows and kind of agentic flows works there as well.
All right, so the next questions, I think this is relevant.
What gives you confidence in the agent evaluation of DeepSeek? I assume the question is related to DeepSeek, the evaluation of DeepSeek. But generally, I would say, we spent a lot of time developing HHEM. This is its 4th version already that's out there. We like any machine learning team out there in the world developing machine learning models. This is a model we developed, we tested. We keep testing it as we develop it and add more data to make the training and the strength of the model better. So yeah, I have pretty strong confidence in HHEM evaluation. Is the high relation versus other LLMs or even LRMs like O3 Mini could be due to different post-training approach compared to others? So I don't think that it's related to post-training. The post-training approach. Yes. So you're asking me like, did OpenAI train differently when they trained the reasoning steps? So we don't know how OpenAI trained. We do know how DeepSeek R1 was trained, given the paper they published. So it's hard for me to compare without knowing the OpenAI side, but my guess would be yes, that DeepSeek needed to take some more care to reduce hallucinations when they trained. Look, when you train these big, large language models, you have a lot of metrics that you measure usually as the team that's training it. And you have to make sure that, as things shift around and you change the weights to be more reasoning, other things don't fall down through the cracks. And I think that's kind of a skill that you have to make sure you apply to your training process. All right. what's your suggestion to mitigate hallucination? For example, R1 using prompt or RAG or more? That's a great question. Generally, I want to make a statement before answering this question. R1 hallucinates a lot, but I still think it's a fantastic model. It's open source. Like, don't get the wrong impression from me. And it is a great model. And I also believe that, you know, the hallucinations will be fixed in maybe the next version of that, although I don't know for sure. To mitigate hallucinations, one of the things I would recommend is, again, if you're using Vectara, if you want to try out a Vectara, you can get the HHEM score. And then once you know something is hallucinated, you can take action based on that. You can either notify the user that this response in your RAG pipeline or in your agentic RAG is incorrect. If you're in agentic flow, you might say, I'm going to ignore this question and ask it the question a different way. You can look of why it was hallucinating, record the hallucinations, and understand why it hallucinated. But also, again, I know people like to use DeepSeek R1. It's great. It's cheap. It's fast, relative to the alternatives. But if hallucination is a really big problem for you, if you're in a regulated environment or some enterprise requirements that hallucination does not need to be there, to be honest, I would stay away from it for a while until they fix it.
All right, not another question.
R1 who's integrated is insane. Do you know the reasons? Well, I think I kind of answered that, but let me repeat that. We don't exactly know the reasons. I think one hypothesis in the previous question was that it's because of some improvements they might need to do to their training process of R1. And I think that will be my guess too, but it's really hard to say without understanding more details about their training process, etc. And one thing to note, we're still investigating this, and so I would expect we might have so keep watch on our blog. We're gonna probably try to publish more results as we find them around this and share this with the community.
Awesome, great. Let me see if we have more questions coming. I think some questions asked about the slides. I think you can share to me. I will share to the attendees.
More than happy to share. Yeah, I'll do that right after this.